welcome back to the channel Maths with Berlin, and here we are with another future JEE advanced question. So for today we have a question on matrices, and this question is basically on the following. It reads as follows. Let me just magnify it for you all so that you can all see it properly. And this is the question. That is, it is given to us that A and B are two 2 cross 2 matrices, right, of real elements. That is an important statement to note. That is of real elements, and these are the two matrices, and it is given that they satisfy the following relation, that is AB equal to A squared B squared minus AB whole squared, right? And the determinant of B is also given to us as 2. Now we need to calculate the value of the determinant of A plus 2B minus B plus 2A, right? So now moving on. So those who want to give it a try, they may pause the video right here and give it a try, and for all the others, let's move on to the solution. So basically, if you just have a common observation, this is of the format of the following, that is, we can write this as A plus xb, right? Determinant of A plus xb, we are trying to solve it in general. Now let's say this is P of x. So let me just tell you that the determinant of this is basically nothing but, I feel, x squared times determinant of B plus mx, I will tell you what is m, and plus determinant of A. I think that is there, or I think this and this must replace each other or something like that, right? That must be there, and a kind of something, and the value of m is basically the determinant of, let's say B can be represented as B11, B12, B21 and B22. In the similar way, let us say that A can be represented as A11 and so on, right? Then basically we say that it is a determinant of B11, B12 and B21, B22, right? The first row of B and the second row of A. You say it like that, right? That is the value of this expression. Let us say that this is a P of x polynomial function. Then the P of x polynomial function can be written as follows. Now you put the values of x as 2 and you get the value of the following thing, right? But for that you need a determinant of B to be there. So that's an important there. And there's another way you can do, which I'll be introducing in the solution part. So just erasing a part of it so that it's clear for you all what is the solution to this problem. So basically, if you see, what I have done is, first of all, I have taken the following thing, that is AB is equals to, wait a minute, AB equal to A squared B squared minus AB whole squared. I have taken that information. Now what I do is, I have that determinant of B is not equal to 0, therefore B must be invertible, right? So now we assume that determinant of A is not equal to 0. If we assume that, what we can do is, you can have a left inverse for A. What is a left inverse? Basically, when you write this A in the inverse of A in the left side, so that is a left inverse, and if you write the inverse in the right side, that is a right inverse. So this is left and this is right, that is all, right? And this was a very informal way to introduce it. A more formal way would be that A, B and something like that. So moving on, but that is not required right now. So that was it. Okay, wait a minute. So what we have is, we have AB is equal to this. Now therefore you get that I is equal to this, because you multiply a left inverse with A, then right inverse with B, and this one most of you would confuse right now, that is AB's whole squared is basically equal to AB times AB and not A squared B squared. This is not equal to this, right? This is AB times AB. I have introduced it in another video why it is so, right? So now the value of the trace, so wait a minute, I am very bad at this. So yeah, the value of the trace, I take a trace on both sides, that I can do, right? I can, if these two matrices are equal, then I can say that the trace are equal, because the elements are obviously equal. Like equality of matrices hold that equality of elements must be there, right? All the elements must be equal. So therefore trace of I can be written as equal to 2, and trace of AB minus BA can be written as 0, right? This can be there, obviously, right? Wait a minute. I was trying to remove this, but it's not working. So yeah. Now there is another lemma now, right? That we introduce another lemma, that is this one. The determinant of p plus q plus r equals to the determinant of p plus q plus the determinant of q plus r plus determinant of r plus p minus determinant of p minus determinant of q minus determinant of r, right? So now this is a mind-blowing statement, but wait a minute, let me just blow it a bit more. This is only valid for a 2 cross 2 matrix, so it's not such a mind-blowing statement, but yeah, you can use it for something to simplify it. So now you get this one, right? What you do here is you try to invoke a plus b, right? You try to write this as follows, and you write this as a plus b. Right now this is, let us say that this is p, this is q, and this is r, and you write this one as p, this one as q, and this one as r for the second determinant, and then you try to solve this equation. And when you solve this equation, you would get the following values when subtracted. And now basically if it is a 2 cross 2 matrix, so therefore determinant of 2b will be equal to 2 squared times the determinant of determinant of b, so that is 2 squared into 2 minus 2, that is the determinant of b, so that is equal to 6. And as determinant of a, we assumed it as not equal to 0, then we arrived at a contradiction, so therefore determinant of a must be 0, that is for sure, right? So that's it for today. And if you want a glimpse of what I am trying right now, right, like what is the next pro video on this channel, so I would like to show you something. So this was one of my previous videos, and there is some more thing that I need to show you. This was something that I wanted to present, but I need more of things, like more content and more audience, so that I can continue with this theory series, right? So I hope you all would share it, and please do like, share, and subscribe the channel, and keep watching for more such mathematical content. Thank you everyone.